Hello and welcome to this week's What Were They Thinking? Amongst this week's news items we have an interesting retraction about face masks, and it's interesting largely because of which publication retracted it. It claims that a popular sweetener can have successive effects on further generations, why it is that a straight cut heals differently to a zigzag cut, orcas are behaving strangely off the coasts of Europe, and rather stunning images from the James Webb Space Telescope, with water plumes spewing from the moons of Saturn. The timestamps for these and other news items can be found in the description box below. Let's start with the retraction of the physiometabolic and clinical consequences of wearing face masks. Systematic review with meta-analyses and comprehensive evaluation. Retraction. The article was retracted for a very simple reason. The publication, Frontiers, found the concerns raised about it, and following investigation, were verified and accurate. This is an unusual action, as Frontiers seems to be loath to retract anything that they publish, yet here they've done so. The idea behind this article is fairly simple. Take all of the existing research, aggregate it, evaluate it, and then see what results you can find based on the best quality studies within it. In this case, they had over 2,000 studies that were looking at adverse effects of wearing masks. 37 of these were considered of acceptable quality, appropriate type, they had the right content and so on for meta-analyses, and these were then aggregated together to get results. The results were fundamentally various claims about the amount of oxygen, the degree of discomfort, so on and so forth. The conclusions they reached was that there is little evidence to validate their use as a protection against things like COVID-19, and that they are not effective, and therefore should not be mandated. This, of course, is another example of studies that fundamentally are flawed from the very beginning. The problem here is several-fold. The first and most obvious is that it is a meta-analysis. In this instance, it's not the appropriate avenue to take, because every study will have its own variations. For example, it had about a 1:3 ratio of males to females, 2,400 versus 6,150. The average age was 34.8 years, plus or minus 12.5. This means that you had wide ranges of age, a very skewed sample size, and the trials themselves had a median, that is, the most common time frame of 18 minutes. That is a problem. You have very short time frames, so you can't really say whether or not breathing in a mask was going to protect you or put others at risk of COVID-19, and that you had huge variations. The reality is that you need specially designed trials to figure out whether or not you can actually wear a mask and be protected. That's a simple reality. This kind of meta-review or meta-analyses isn't going to do that. Next we have the actual effects of COVID, and specifically long COVID. Long COVID is a broad category of effects people experience after being infected by COVID-19. And it has a huge number of possible symptoms, more than 200. This means that we now have a large population with many different symptoms, and they often last for 6 or more months. As a result, knowing what's happening and how to deal with it is important, but we don't have a way to deal with it. This is where a National Institute of Health investigation is going to be useful. Admittedly, it is a very small sample size, so take it with a lot of salt at this point. It involved 12 people with long COVID and a matching group of healthy people who did not have COVID. They looked at blood samples, cerebrospinal, MRIs, and a variety of other tests that could be run against the individuals without putting them through undue discomfort beyond the idea of shoving a needle into their spine for cerebrospinal fluid. Those who had long COVID were largely females who were 40 or older, and they experienced their infection about 9 months ago. The major finding was that they were experiencing similar symptoms. These were largely things like cognitive decline and fatigue. This alone is interesting, but it's the possible relationship it had to the greatly reduced number of memory T cells. Memory T cells are the cells responsible for ensuring your body can mount a response to a viral infection again. They're basically at its simplest, the memory T cells are what your body keeps in storage so that when you're exposed to a pathogen, or for that matter a tumor or anything else that the body wants to dispose of, it can awaken them. They then get turned into active T killer cells and they go off and attack the target. Once they've done their job, the excess ones are removed and some are put back into memory cells once more. This means your body can always mount a robust response to any possible pathogen it encounters or thing it wants to get rid of, like for example infected cells. Without these, however, you're going to struggle a lot more. Further, you had increased B cells, which are what are going to produce your antibodies that circulate around the body in an effort to detect and flag possibly infected cells, virions that are floating around waiting to find a new cell to infect. There was also an increase in natural killer cells, which are intended to destroy damaged cells in your body. Further to these changes that are fundamentally what you can measure inside the blood as cell count, there was also a change in the genome, but particularly around checkpoints with regards to immune cells. And this means that the body is trying to make sure that cells are making sure they're produced correctly. But importantly for these, the checkpoints that were affected are those that indicate immune exhaustion. That is, the body has had to work for so long and so hard that it's starting to run out of cells that it can push out soon enough to mount a defense. This is something that really only occurs if you have, say, infection or cancer, where the pathogen the body's trying to deal with isn't able to be resolved in a very quick manner. But with COVID-19, these individuals had theoretically had the virus cleared from their body, which indicates that the body was still trying to clear out the virus long after it had been removed. This is a sign that there's some sort of checkpoint failure, or that there's an abnormality leading the immune system to keep trying to fight it off. And that does explain part of the fatigue issue, as the body's putting a lot of effort, resources, and time into making immune cells, and this is draining from other places that you could be using that same energy. In short, the research isn't very conclusive, as we now know something about the effects that are happening in long COVID. What it does indicate is that there's a possible avenue to use immunotherapies to fundamentally cap the activity of the immune system and thereby reduce its activity and the impact it has on the body. Sort of a have you tried turning it on and off again approach. Moving to sweeteners and how a animal study, so again this involves a lot of salt, could be having effects on successive generations of mice for those who have been fed it. Understand this is very preliminary and we have a lot of questions about it. The sweetener in question is aspartame, and as we've mentioned before, aspartame is, at least as far as all research at this stage shows, overall safe. And to be clear, that's the overall position. You will always find individual studies that will deviate from it. The first thing to state here is that the mice were fed a very low dose, about 15% of the recommended maximum daily amount. They then observed their behavior, and the researchers say that they displayed anxious behavior in mood tests, but they had to specially design these mood tests, and they don't state whether or not they were, let's say, verified tests for this kind of research. But that's another issue again. When looking at them, they found that the next two generations also exhibited similar behavior. The researchers also found that there were significant changes in the amygdala, which is the emotional controlling part of the brain, which, to be quite blunt, isn't that surprising. Most mice involved in research are going to experience some degree of anxiety for a range of reasons, not the least of which is that they don't have a very long life. The researchers do believe that part of this whole situation boils down to how aspartame is metabolized. It turns into aspartic acid, which is one of the essential amino acids, phenylalanine, another amino acid, and methanol is somewhat poisonous. The researchers do rightly point out that this research was only conducted in mice and that it needs to be replicated in humans to have any kind of hope of being a real clinical significance. But despite that, it is worth being aware of it and arguably saying, okay, we know about this, now do we need to be aware of the FDA's maximum amount? Do we need to be concerned about multi-generational impacts? And perhaps most importantly of all, and this should be said with a great deal of reticence, is aspartame safe? Shifting to actual clinical news and a brain and spine implant that has allowed someone who was paralyzed to move once more. This is not the first such device or development. Over the last few years, there have been several such implants. Some have returned eyesight to individuals, others have done very similar to this in that they have allowed movement for those who have had damaged spines. This is where the 40-year-old male named Gert Jan, who was injured with a biking accident more than 10 years ago, is at least somewhat helpful. Many of the other studies and implants have looked at either people who have been injured on very short-term bases or much longer bases. And this is where it's helpful to see whether or not there's some sort of intermediary or middle group where you could use this implant to greater effect. More so as a trial, very first patient zero, for this sort of implant based in Switzerland. Unlike other devices that have been developed that were effectively permanent implants, this may not need to be permanent, or at least may not need to be permanently active. One of the implants sits just above his brain, and it analyzes and interprets these signals, telling his body that it should be moving in particular ways, in this case walking. This is then sent as a signal to his spine where a second implant is located, and it's wirelessly sending the signal, so you don't need to have that section of spine intact, or for that matter have wires running down his spine. This allows the signal to be sent to the part of the spine, which then translates to his lower limbs, and this then lets him walk. By itself, that's useful, as a lot of earlier generations of these devices were physically wired together. The more important development, other than it being wireless, is that over time, it was able to restore some of the damaged connectivity in his nervous system, thereby allowing him to walk without the implant being active. This would be a huge benefit in rehabilitation and recovery for individuals who have received similar injuries, particularly if they've hit a recovery plateau, where through things like physiotherapy, occupational therapy, or other kinds of rehabilitation, they simply aren't getting any more results. In further recovery-based news, we have the difference between a direct straight incision or an incision made of zigzag cuts. As a general rule, a straight cut is preferred for a number of reasons. The first and most simple is, well, cosmetics. People prefer to have what looks to be a straight, neat line rather than a zigzagging path across their skin. Surgeons also prefer it because it's much simpler to do so. Research from Singapore indicates that the two choices, that being zigzag or straight, may in fact have very different surgical outcomes as far as the way the wound heals. A zigzag cut heals up to 5 times faster than a straight cut would do, and this should also be taken with a lot of caution, because they were using biosynthetic materials, and they only ran the test over 64 hours. So again, take this with a lot of caution. The researchers were not only looking at the rate at which the healing occurred, but more importantly, how the healing occurred within there, particularly the movement of cells. Using different sized curvatures of the cuts, they were able to figure out that when you have a straight cut, the cells move largely along the edge of the cut. When you have a cut that goes up and down or zigzags, the cells have to eddy and whirl and they get stuck due to turbulence. That turbulence leads to much more time in which the cells interact and begin connecting and therefore healing the wound much sooner. This means that the opposite sides of an injury can connect and form a bridge much sooner, and that means they heal much sooner. Going to more chronic disease and clinical news, we have a relationship between certain viruses, and particularly one, and the development of multiple sclerosis. Multiple sclerosis is an autoimmune disease that is degenerative. Over time, your body breaks down due to the way the immune system attacks it. It largely targets the brain and spinal cord, although you may find peripheral damage leading to things like neuropathy. The initial symptoms are fairly mundane. It includes things like fatigue, vision problems, but these eventually get worse with mobility and balance, and then finally cognitive dysfunction. This comes in waves where you may have periods of recovery, but then you have periods where things get worse, and you don't tend to recover to the same extent to which you deteriorated. The problem with MS is that it's basically unknown as to what exactly causes it. There are various theories, but none have been proven to be the exact cause. One of the leading theories is that Epstein-Barr virus as a child could lead to it, but it's unknown if that's exactly what's causing it. The research this time is useful, not necessarily because it's found something new by itself, rather it builds on the existing research. That is, the roughly 700 individuals with MS and the 700 who were matched to them were examined to see what was present and what was not present. Importantly, what was present is antibodies to a particular protein called EBNA1. This is present at higher levels in those with MS. This is also well-known research already, so that wasn't much help. It's the relationship that that protein had to another very similar protein in parts of the brain, called alpha-crystalline B. The antibodies target a part of the immune system that's meant to control inflammation, and particularly in the brain. And if you have inflammation in the brain, you have a more active immune system there, along with various issues related to inflammation, such as swelling. This could explain some of the issues to do with deterioration and decline in cognitive function. Importantly though, only a fraction of individuals that they looked at had this. Also, another fraction of the control group had this same situation. The difference is that 23% of MS patients had it, and only 7% of those who don't have MS. In a healthy individual who doesn't have autoimmune diseases, this would basically be an indication that you had some sort of disease and the body would deal with it fairly quickly. However, with MS, because it's an autoimmune disease and the immune system starts to attack your own body, it is entirely possible that T cells are responsible for not only being more active in the brain and attacking your body, particularly the brain, but also the rest of the central nervous system and some of your peripheral nervous system, because it is detecting that protein as a foreign pathogen. This also explains some of why the recovery comes in ebbs and flows. That is, you have a period where the immune system is stimulated to act, it attacks your brain and your spine, causing damage. You then have the immune system go back to its sedentary state and you start to recover. But damage to the central nervous system isn't really able to be recovered to the full extent possible. This would also explain why it is that immunotherapies targeting T cells and trying to prevent relapse seem to be effective at slowing down deterioration even if they don't entirely prevent progress of the disease. Shifting to weird animal news, we have orcas sinking boats off of Europe, and we're not entirely sure why. The orcas living near the Iberian coast have struck and sunk several ships near the Strait of Gibraltar. That's the area just below Spain and above Morocco. We say sinking multiple boats, but really there's only been 3 since May 2020, and this may or may not be part of a wider pattern. Since May 2020, a female orca was the first to sink a small yacht. This small yacht was, well, a small yacht. The sailboat apparently annoyed the whale, but that's the first example, and then there have been 2 more since. The behavior is weird, not so much because they're attacking boats. After all, anybody who has ever been near a whale for tourist reasons would know that you shouldn't go too close to them, as just surfacing alone can capsize a boat. It's not the surfacing of the whales here that's causing the damage to them. Rather, they're specifically targeting the rudder. And because each of them has done exactly the same thing to disable the boat, it tells us that there's some sort of commonality to what's happening. The reality is that nobody knows why these orcas are doing what they're doing. However, one theory is that it's purely curiosity. That is, they want to know what's going on with this bizarre thing in their environment. So they go up to it and they basically start fiddling with it, like a child finding a new toy or something they're curious about. Moving from bizarre orca whales to how you can turn a lizard into a bird, or more accurately, how you can turn scales into feathers. This is an important evolutionary step between dinosaurs and, for example, chickens. Not only is it important from an evolutionary point of view, but it also explains how it is that we have roughly the same genome in some respects across multiple different areas of life, yet it's revealed itself in very different ways. In this case, how a small change to just a few genes can lead to you either having something like scales, or you can wind up having something like feathers. At least this research involves one of the few remaining genes with a fun name, the Sonic the Hedgehog gene. This is what's responsible for chickens growing scales on their feet rather than feathers. After modifying it just slightly, the chickens had feathers on their feet rather than scales. To make sure that what they were testing was accurate, they had viable chicken eggs develop with embryos within them. The embryos within were broiler chickens that were intended to have very unfeathered and scaly feet. This is a practicality of how you can ensure that the chicken has the least chance of developing complications while growing. While still in the egg, they injected the veins within the chicken with a substance that promoted the Sonic the Hedgehog pathway. This triggered feathers to grow, and this meant that you no longer have scales, but feathers. Unlike other treatments, this didn't require any long-term work. Rather, it was something that could be done with one single treatment and shows how a single mutation, or more importantly, one possible exposure during development in the egg for whatever reason, could lead to the development of feathers instead of scales. The final news we have for you is more images rather than actual news, but they're stunning images for what they are. They are from the James Webb Space Telescope, and it shows water plumes from the moons of Saturn. The moon itself that we are speaking about is Enceladus, and it's one of Saturn's moons. It's also covered in solid ice, but underneath that is a moving ocean. The idea is that as the moon itself has had very geological activity over time, it causes the ice to break free and the water under pressure underneath due to the heat to come out as a huge plume of vapor. This is not just important news because the images are stunning, but that is true as well. Rather, the telescope is located here on Earth, or at least in orbit of Earth. The next closest facility we have would be Cassini, which was located around Saturn, and it was fundamentally monitoring Saturn, by virtue of which we were able to get basically collateral images of what Enceladus was doing with these plumes of vapor. The vapor plumes not just indicate that there's awesome images to be had, but also the possibility of life. The geological activity, and particularly geological vents on Enceladus, could be a way for life to exist, and it's most likely the place that we would find it, at least for now. The reason for that is that it is effectively an ocean planet, even if the top surface layer is frozen. Underneath that, you have heat, you have water, and you'll have chemical reactions, meaning there may be very fundamental life on it. These plumes of water are more an indication of that geological activity than anything else. This is why, although the very first images we're seeing now aren't exactly revealing a great deal, it also wasn't looking at it for very long. The second round of, requested viewing opportunities with it have now included another study of Enceladus that will look at it for 6 times longer. And the idea with this study is to see whether or not they could find chemical compounds that may indicate either organic substances, these are primarily carbon-based things, or possibly other indicators of life at its best. Admittedly, these are only indicators, not actual life. That's all the news we have for you this week. Thank you for watching. If you have found it interesting, consider liking, sharing, and subscribing. Please post any comments, questions, or suggestions you have below.